The mean value theorem for derivatives, MVTD short. So the theorem states if y equal to f of x is continuous on a closed interval between a and b, and is differential everywhere on the interval ab, then there is at least one number c between a and b such that the derivative of the function at c must equal to f of b minus f of a over b minus a. Now, what does that mean? Let's take a look at the picture. This might help. So say you have a function f of x here, okay? And we're going to pick 2 points randomly on this function, a and b. Now we know that a and b is in the interval, okay, some sort of interval. That in this interval here, that's continuous. That's important. It has to be continuous. And then the theorem states the slope between these 2 points. Here's a slope, right? F of b minus f of a, y2 minus y1 over b minus a, x2 minus y1, x2 minus x1. So the slope between these 2 points on the function, there must be another number c in between a and b where the derivative at this point also equal to this. So this slope equal to that slope. Okay, that's what the theorem states. So let's see how we can use this theorem. So example 1, suppose you have the function f of x equal to x squared, and you look at the interval between 1 and 3. The MVTD states that that there is a number c. So use the theorem to find c. Okay, so we use our definition. So f prime of c must equal to the slope, right? Slope. Okay, so of between these two x values. So the 3 minus 1 is on the bottom, right? And the top, we're going to just plug it in 3 and 1. So you have a y2 minus y1 over x2 minus x1. So f prime of c must equal to this slope. So we know that, so when we take the derivative of x squared, okay, is 2x. So 2x must equal to 4. So now we plug in c. There must be a number c at that point. You have this slope will equal to that slope. Therefore, c has equal to 2, according to the mean value theorem. Now let's try another one. Okay, example 2. Consider f of x equal to x cubed minus 12x over the interval -2 and 2. Find values c that satisfy the mean value theorem for derivative. So the first thing we do, we're going to take the derivative, okay, of the original function. Then we know the derivative at c must equal to the slope between -2 and 2 on the function. So we take 2 minus -2, that's going to be our denominator, and we're going to plug in -2 and 2 separately into our original function. So you get the y2 minus y1. So the slope on the function between -2 and 2 is going to be -a. So we're going to set our derivative, now evaluate as c, because it must be a number at c. They have the same slope as -a. So once we say 3c squared minus 12 equal to -a, we solve for c, then c will give us approximately 1.55. But now remember, we say we want the c, right, has to be between -2 and 2. So if you look at our answer, make sure both the answers are in our interval. Okay, in this case, okay, it is, so we're okay. Now, so remember, you can have 2 answers because the theorem states at least one c. Okay. Let's do another one. Same thing. Okay, example 3. When f of x equal to 1 over x on an interval -2 and 2. So we want to find c using mean value theorem. So we take the derivative of 1 over x. So it's -1 over x squared. So this derivative at c, okay, which we're going to be on this side in a minute, must equal to the slope of these two, between these 2 points on 1 over x. So we plug it in, f2 minus f -2, 2 minus -2. That might be easier to see. You see the y2 minus y1, x2 minus x1. So the slope is 1/4. So -1 over c squared must equal to 1/4. Notice c has no solution. You can solve this because if you cross multiply, you get c squared equal to -4. There's no such thing. It's imaginary, right? Okay. So, well, why? Because if you graph 1 over x, if you the graph of 1 over x, at in the interval -2 and 2, it's not continuous. Remember, one of the most important thing is the function has to be continuous for the mean value theorem to work. Now, Rolle's theorem, it's just a very special type of MVTD. So it's the same thing, except when we're looking at the slope happen to be 0. So if you look at this curve here, f of x, okay, if fa and fb happen to be 0, in other words, the intercepts. So if you look at these 2 points, now your slope is going to be 0. So we're only looking at the slope 0. So they're saying, okay, so same thing using mean value theorem. If the slope between A and B happen to be 0, you must find that C, they also have the same slope, which is 0. So dealing with the when fa equal to fb equal to 0, then the f prime of C must equal to 0. So it just happened to be 0 for the slope. And this particular um, situation, we call it Rolle's theorem. Okay, so let's see how this is being applied. So find value of C that satisfies Rolle's theorem for f of x equal to x squared over 2 minus 6x on the interval 0 and 8 and 0 and 12. Right, so we do exactly the same thing. Okay, so first of all, take the derivative. Then we need to verify that you use Rolle's theorem. F of 0 and f of 12 must equal to 0. In that case, then we just have to take this derivative, evaluate at C equal to 0. So C minus 6 is 0, therefore C equal to 6.